So we're looking at Chapter 8, Lesson 3 on scientific notation. This is basically when you're looking at very large numbers or very small numbers and you want to make a comparison between them. Now the biggest thing here that you need to remember about scientific notation is it's always a non-zero number that is one place to the left of the decimal point. So it has to be something like 2.35 times 10 to the 7th. You have to have one number that's not a zero to the left of the decimal point. That's scientific notation. All right? If you don't have at least one non-zero digit to the left of the zero, then it's not scientific notation. And they'll try to trick you on that with a standard test. All right, so in the examples here, they want to express each number in scientific notation. Now, you can have all of this, and that kind of really explains it. But basically, all you're doing is you're taking the decimal point that's understood to be over here, and you're moving it right here. So how many places did you move it? Well, first of all, we rewrite it with one non-zero number to the left of the decimal point. So it's 2.99 times 10. And how many places did we have to move the decimal point? Well, 3, 6, and 2 more is 8. So there's your answer. 2.99 times 10 to the 8th power. All right, so that's how you do very large numbers. Now, the other possibility is you have very small numbers. So in this situation, you have to think about, well, okay, yeah, it's a small number. Basically, it's the same idea, though, that you're moving the decimal point. So how many places do you need to move the decimal point from here to here? So it's going to be 2.54 times 10 to the what power? Well, we moved it 1, 2, 3, 4, 5 places. And you have to think that it's really a number that's less than the value of 1, so it's going to be a negative exponent because of this whole scenario. We're dividing by small pieces. So it is 2.54 times 10 to the negative 5th. All right. Now, if we go backwards and we have a number that's in scientific notation and we want to change it, then all we have to do is think about multiplying by the power of 10. Anytime you multiply by 10, you move the decimal point that many places. So if I have 3.14 and I'm going to multiply by 6 tens, I'm going to move it 6 places. So I go 1, 2. All right, so I got 4 more to go. 1, 2, 3, 4. So there's my new decimal point. And I can just fill in the zeros. All right, so my answer there is going to be 314,000,000. Obviously, put the commas in there. So we come over here 1, come over here again. So we have 3,140,000. That is the same value as that right there. Now the other piece is, if we have a negative exponent, that means we're going to actually divide by that number, so the number actually gets smaller. So we're going to move it in the negative direction. So we have 7.2. We're going to move it 4 places. So if I move it 1, how many more places do I need to go? 3 more. All right, so I need to put in 1, 2, 3 zeros, put in the 7, 2. Put my decimal point here. Now, you obviously don't just write the answer like that. Make sure you put a 0 in front of it. Any good math science person would do that. All right, so your answer is going to be 0.00072. All right. Moving on to your next slide. Now, here it says express each number in scientific notation. All right, so we're just changing into scientific notation. We have 3,500. So we have to have one non-zero digit. So we have 3.5 times 10. How many places do I need to move the decimal point? All right, so I need to move the decimal point from here to here. So I need to move it 3 places. All right, there's your answer there. Oh, let's see. We will take and do number 2. I have 0.0015. I need to move the decimal point, so I have one non-zero digit right there. So I get 1.5 times 10. Now this is a small number, and we're moving in to make it a smaller number. So we're actually dividing by powers of 10. So this becomes a negative exponent. We move 1, 2, 3 places. That's why we have a negative exponent there. All right, number 3, we have 43.8. I want to change it into scientific notation. This one, it's not moving very far. It's only moving over one spot. So I get 4.38 multiplied by 10 to only 1 power. Now you can leave the 1 there. You don't have to have it either way. Number 4, I have 285 million. Now remember, you have to have one number to the left of the decimal point. So 2.85873. Now you don't need the zeros. So we say times 10. Now how many places did we move it? Well, we have 3, 6, and 2 more. So we have a total of 8. All right, so 2.85873 times 10 to the 8th. All right, moving down to number 5. I have this weird number here. I need to move the decimal point from here all the way to here. So how many places do I move it? 1, 2, 3, 4, 5, 6, 7, 8. So 4.85 times 10 to the negative 8 power. All right, I think you have enough of that. Let's move on to where you can actually start doing some operations with this. All right, so now we're going to multiply and divide, and here's where those rules really come into play here. So we have number 9, we have 5.4, 5.4 multiplied by 10 to the first. That term being multiplied by 4 times 10 to the 4th. Now this is where you can think of the commutative property. You can move things around. Doesn't matter. You still come up with the same answer because everything is being multiplied. So basically what I'm going to do is multiply 5.4 times 4. And when I do that, I get 21.6. And then I use my rules of multiplying bases with like bases by exponents. I just add them. So I have times 10 to the 5th. Now when I do that, it looks like it's in scientific notation, but it's not because I have 2 places to the left of the decimal point. So I need to change this. I need to move the decimal point. That's located here, and I need to move it over here. So I get I get 2.16 times 10. Now the question is, what do you do with that? Is it to the 5th? Is it to the 6th? What is it? Well, it actually is to the 6th. All righty. Now, moving on, we go up to number 11. We have 9 times 20. Well, obviously that's 180. We have 10 to the 6th. Now remember, if you have like bases, 10 and 10, you can just add the exponents. So I have 6 minus 4 in this situation because I'm adding a negative. So 6 minus 4 gives me times 10 to the 2nd power. Now, that's not very nice number. I have 180 times 10 to the 2nd. I need to get an exponent. So I have my exponent, 10 to the 2nd, but I have a decimal point. It's understood to be right there, but I need to move it here. So I get 1.8 times 10, but what does that become? Is it 10 to the 2nd? Is it 10 to the 4th? What does it become? Well, you've moved it 2 places over this way, which actually means that you have to multiply by 2 powers of 10, so you have to have 1.8 times 10 to the 4th. Alrighty. Moving on to number 12. I have 2.6 times 10 to the 3rd being divided by 6.5 times 10 to the 9th. At this point, we can look at the tens. We have 10 to the 3rd divided by 10 to the 9th. Remember your rule. If you have like bases and you're dividing, you can simply cancel things out. So I actually have 10 to the 6th on the bottom. And 2.6 divided by 6.5 gives me 0.4 times 10 to the negative 6. Now the question is, it looks like it's in scientific notation, but it's not, because I have a 0 to the left of the decimal point. I need to move this to here. I need to make it 4.0 times 10.